But we will not settle for just spirituality, although some of us love that, because we need to know more. What is it about this damn plant that makes it so special? What is it about this plant that the Native Americans have considered magical for literally thousands of years? So today we're going to do something that we haven't done before. We have an amazing gentleman to my right, Ivan Saldaña.mov. He's a scientist. He's born and raised in Guadalajara. He's had agaves around him his entire life. He studied plants and got his doctorate in England on botany, but he got into the whole drinking thing. He started working in distillation and fermentation and got fascinated by this. He now has a company called Organica Consulting, and it is actually because of the good graces of our dear friends at Pernod Ricard and Olmeca Tequila, where he has done a bunch of consulting, that he is here with us today. But as the native cultures consider the plant magic, let's now find out what it is about that plant that's so magical. Let's find out what it is about that plant that makes these magical beverages. Let's break down the science of it, and let's give a big warm welcome to Ivan. Ivan?
Thank you, Chris. Well, I'm so amazed about how much you can learn in a cocktail week like this one. So the black magic behind the bar is still very complex to me, but I think this week has helped me to understand better. And that's what I will try to do with a little bit of science here. I will try to make it fun and to make it accessible. But more than anything, I hope the information I will be providing will help you to understand better agave, the real spirits. You will see my English is not my first language, so I may have a few mistakes. So why is it important to understand agave? Well, because a lot of the differences between products are coming from there. Yes, the process has a great deal and a great effect on what the product, the finished product is, but the agave has a lot of peculiarities that are making the tequila and the mezcal what these products are. So, I will use this. This is better. Well, so there's three main concepts I want to share with you today. One of the concepts is to explain a little bit about the natural history of this plant. Well, when I'm talking about the plant, I'm talking about the genus. I'm not talking about a specific species. Actually, the agaves are of many sizes and weights, and leaves may have more spikes or less spikes. But generally speaking, they have a common ancestor, and their biological function are quite similar between them. However, so there's a lot of things in common with agaves, but there's also a lot of different things between different agaves, even from the same species or variety, depending on how these plants are actually grown. So in order to understand why all these plants are so similar, but at the same time, how being so similar they can actually exhibit so many differences, well, I will try to talk about the past, the natural history. I will try to explain how the plant actually works in terms of a little bit of the metabolism and the plasticity, so the ability of these plants to adapt to different conditions. And finally, I will try to give some examples of what scientists have found already about terroir, about how a product can change depending on the raw material you are using. There's still a lot of science that needs to be done, but at least there's some stuff around there that I will try to share with you. I can use this. Well, the first thing you need to understand is that agaves are response to adversity. So it's the product of evolution running on a plant for 10 million years in very difficult conditions, what is actually shaping this plant. And well, stress has many meanings in the dictionary. Stress can be a pressure or tension measurement. It can be considered a state of a mental or emotional state. But stress for biologists and doctors too are related with the concept of having a living organism in edge conditions, in conditions in which well, doesn't feel very comfortable. And when you have a plant growing in stress conditions, you have a strong selective forces playing over it, and that will make this plant to develop in strange ways along many years. So the stress that agave is subjected to has been from all these 10 million years. Well, some of them are physical, so the plant developed in a very arid area in the Americas. Is a plant that comes from this continent only. Aloe vera is not American. Aloe vera comes from Africa, although they are related. But okay, let's go back to the agave. So agave has been subjected to a lot of drought, a lot of heat, and a lot of cold. And for that, the plant has evolved in a succulent way. You'd see all these leaves full of water. They have a thick cuticle. They have waxes in order to avoid the water to be released, so the plant can keep as much as it can. And also a more sophisticated metabolic pathway, such as the CAM, the crassulacean acid metabolism that I will explain later, and the fructans. The second group of stresses are biological. So you can imagine that if you live in an area where water is so scarce, where everybody wants the water, and if the water is in a plant, well, they will attack this plant. So the main biological stresses are insects, herbivores, and microbes. And the agave plant has evolved complex compounds that provide flavors that you can actually find in the tequila, in order to avoid microbe and fungi growth in the plant. And also a very scary physical tools to keep herbivores away, like the spikes, but also other microscopic pieces, crystals called oxalate crystals that you will see later on in this presentation. So I'm just trying to explain all the different forces that have been there for 10 million years. And evolution works thanks to 4 ingredients. One is time, a lot of time. And the other 3 are basically the ability to multiply, so to generate populations, an ability to create variability. So there you have a mutation factor, which is happening all the time. There's always random changes between one organism and another, actually between one cell and another. And also some sexual reproduction. In agave, that is not that common. It's almost inexistent in cultivated agave plant, and well, there's some sexual reproduction in wild plants. And finally, the selective forces I was talking before, that are all these stresses. When you put these 4 ingredients together, you actually get evolution. I will go very fast. This is just showing how you can get sexual and asexual reproduction here. From one plant you can get many. Then you can get mutations. And well, this is the important thing. Once you get a population, all these selective forces will start to kill or avoid reproduction of a lot of these plants, and you will keep only a fraction of them. And those are the ones that can actually cope better with the selecting factors. And generation over generation, they will fix a specific characteristic. So, I haven't said something that is really important. A part of the natural forces, you have a very powerful one that has been used for 9,000 years, no more than that. So 10 million years of the natural selection in the continent, 9,000 years of human selection just after the man crossed through the Bering Strait. At least is what we theorists said, and evidence are there about that. So the agave is less human than you would imagine. I mean, if I could write a line along this room, I will give a whole round with my pen, making this line, and probably 5 centimeters will be, if I'm representing time, the amount of human involved in these plants. But of course, human can do things very, very fast. And of course, those 9,000 years has a lot of impact in what agave is today. Blue agave and all the other cultivators agaves too. So I will try to go faster, but I don't know how the clock is going. But so the agave plant, it could look a little bit boring, but I'm going to do it very fast. Can I point this? Is this a laser? No. No, don't worry. Well,
It might be.
the agave is a flowering plant, so it's an angiosperm. The agave is a monocot, not a dicot. Monocots have a certain pattern for growing, like maize, like circular. And dicots tends to have these, two branches and then another two branches is a kind of a pattern for growing. And below that is the lilies. The lilies is a very large group. We eat a lot of lilies in our everyday diet. You will see later on some of the most those related. And well, then is the agave and the agavoide, where yucca is also as well. And well, within the agave we have other friends too. But well, this is where the agaves are actually organized. So I said already that agaves are endemic from America. You can naturally found it between Utah and Venezuela. In Mexico, the central place where speciation occurs. When you say how many species of agave are there, you can actually choose any number you want. As far as it's between 150 and 300. It's not very easy to say if one agave and the other agave is actually the same species or not, or a variety. Because like the proper explanation of a species is a little bit arbitrary, but it's supposed to be that when you have a child, or let's say when the offspring is capable of having offspring as well, and you have crossed two individuals, then they are the same species. But it takes so long to grow agaves, and it has a very complex polyploidy. They multiply the chromosomes in crazy ways, and things I don't want to share too much because it will take very long. It's very difficult to say if one agave variety is actually different from another. And this is going to be a very important concept I will retake later on. So the close relatives are plants that we know very well. Onion and garlic. When I was doing some molecular studies on the plant, well, I got a lot of genes that were almost identical to onion and garlic. And there are lilies as well, like pineapple and asparagus and artichokes and nennuphars and plant trees. Those are the close related ones, but don't get confused. Some people think cactus are close related with agave. Well, they are as related as a butterfly and a bird, because both have wings, you see. These two plants have evolved with similar strategies to cope with harsh conditions. But that doesn't mean they are close related. They are quite far away. It's much more similar to your asparagus in the dinner than to the cactus. Okay, well, I will just here be very fast because I will get focused into the biochemistry, but I just want to put some examples of what evolution can actually create. Leaves, well, when you see these leaves, you are very familiarized with this photo, but what you probably don't realize is that the shape these leaves are like this is because when it rains, the leaves can actually capture much more water and send it immediately to the roots, which are designed in a very perfect way to absorb a lot of water very, very, very fast. Actually, there's roots that grows just when the rain arrives, and they are there for 1 or 2 hours only. Well, you have spikes, but you also have imprints of spikes, and this is for saying the herbivores go away. Well, this is a nice oxalate crystals. People that work with agave knows that if you touch your skin with the agave surface, you will start to get a rash, and this is because these crystals of oxalate will start to penetrate. This is not random. This is the way the plant is defending against herbivores. Well, this is an electron microscope photography, and that is huge cells, like 20 times bigger than normal plant cells, for keeping water and sugars in the leaf and in the plant. Another scary photographs of these oxalates. Well, you know this very well. This is the succulents. I just wanted to point out that this plant can actually store a lot of water. This is a photo showing well, a leaf or even the pine, because all the agave makes photosynthesis in the surface. But if you go a little bit into the plant, it will be just a storage tissue there. And well, these little photographs is important. The cells there are called stomata, the little windows through which the plant can actually let the CO2 get in. Because yeah, you get the water through the roots, but in order to make sugar that then will become our drink, you will need to get the CO2, and that's very, very expensive in terms of water loss. So I'm closing this photograph here in order to move into the biochemistry, and that little cells that are all along the leaves are actually the little hole through which CO2 enters into the plant.
Mr. Cooper, telling the truth, man.